So first off, generally the nerve structure is different. I've got the somatic nervous system here, which generally has just one long nerve fiber which goes to the effector. I've drew a skeletal muscle there, obviously. You can tell because of the striations. Yep. And they don't synapse at ganglia, okay? Our autonomic nervous system, though, generally synapse at a ganglia, so a cluster of unmyelinated neurons. So you have your pre-ganglionic axon and your post-ganglionic axon. And then the ganglia in the middle. All right, so one part of the autonomic nervous system has a relatively short preganglionic axon, and then the other has a relatively short postganglionic. So by looking at these, which is which? So you can go back to your worksheet. Which has kind of when you look at them, which has a short and which has a long? Okay, good. Yeah. So
say it's a ganglion, is it like one cell body or a cluster of cell bodies?
So it's a cluster, right? It's a bunch of neurons unmyelinated all together. Yeah.
Is sympathetic equal then?
Well, just when you compare, not necessarily equal. Has shorter pre when you look at them together. The parasympathetic has a longer preganglionic axon.
So is the sympathetic nervous structure like the whole middle part, or is that just the preganglion?
Is that better?
Yeah.
Okay. All right, now you know some of the names of these ganglia, right? All right, but that's one of the big differences then between structurally between the autonomic and, between the parasympathetic and sympathetic nervous system. All right, so some of the other characteristics then, when you look again at our figure here, our parasympathetic nervous system is craniosacral in origin. All right, so most of them come off of cranial nerves, okay, above the chain ganglia and sympathetic nervous system, or towards the bottom, sacral nerves. Okay, the parasympathetic nervous system is also our rest and digest. And normally it uses acetylcholine as its neurotransmitter. And so that is one way in which these nervous system types then differentiate themselves at the effector, at the organ. So if acetylcholine is released, then it'll have a parasympathetic response, which is generally going to be a slowing down of the metabolic activity, the rest, or an increase in the metabolic activity if it's involved in the digestive system. All right, and we know now then the main cranial nerves. And there are 4, and what were the 4 that we talked about? Oculomotor, facial, vagus, and glossopharyngeal. And most of them go through our vagus nerve. Okay, so that's our parasympathetic nervous system. All right, and then we also, what we said before, we have long presynaptic ganglia, or preganglionic axons, sorry. And thus short postganglionic axon.
It's long preganglion axon.
Long preganglionic axons.
Okay.
Short postganglionic axons. Oh yeah. All right, so then when we...
Oh, wait, sorry. Is it?
Okay, and we'll actually skip this. We already talked about the cranial nerves. And then sacral S1 through S4 is where the sacral parts originate. All right, our sympathetic nervous system then. Well, this is our flight or flight response. Okay. So, yes, this is activated when you are startled or scared. Right? And sometimes this can have immediate consequences on your parasympathetic nervous system. So, for example, if you've ever been really scared and you pee just a little bit, right? It's because, you kind of got thrown out of whack, right? The sympathetic nervous system got turned on all at once, and your parasympathetic nervous system kind of got turned off a little bit. Or if you've maybe even pooped your pants, right? It's even worse. I've never been there, but I've heard of it happening. Yeah. So a lot of marathon runners actually will, have pooped their pants because,
You can't control it.
yeah, or they just don't want to stop, or they ate too much before they.
I ran past
Yeah.
Angela last year, and our best runner, she finished her race, and she couldn't control her bladder anymore, and she went up to give one of our teammates a hug, and she was just peeing, and she couldn't help it.
Yeah, right.
She was alone.
It happens. Okay. All right, these are thoracic in origin, so mostly along T1 down to L2. They have mostly synapse at chain ganglia or these splanchnic nerves. Okay, and so they have relatively short preganglionic axons. So they synapse further away from the effectors, from the organs and the parasympathetic nervous system. All right, was there anything else? So our neurotransmitter there's two main ones, and this is epinephrine and norepinephrine. Okay, also known as adrenaline and noradrenaline. And so again, if you want a sympathetic nervous response, the sympathetic nerve fibers will be stimulated and release epinephrine rather than acetylcholine. Okay, so this will turn the digestive system off, essentially, as acetylcholine turns it on, and then other areas, like your heart, would then beat faster after being stimulated by epinephrine. Okay. So the pathway then, we have, remember we talked about the rami communicantase. Which were part of the ventral rami. They split off the ventral rami. And I colored it in there. You can't really see very well. But you have the gray one and the white one. And we know that the ventral has efferent signals, right? So these are originating, these are these are viscero motor. So it's coming off our lateral horn. And then it's going to synapse with the chain ganglia. It comes in the white rami. Okay, synapses at the chain ganglia, and then out the gray to the effector.
Sorry.
Okay, so if you want to draw arrows on here, this is the direction it's going. But they don't always necessarily go at the collateral ganglia, which is closest to them. So this is one option, is where it comes out of the spinal cord, it'll synapse with the chain ganglia closest to them. But sometimes they can go above, so they would go in the white, go up to another chain ganglia, synapse there, and then out the gray at that one. Or it can go below even. So it can go above or below, or the same, at the same level. Okay, so our three options are: one, at the chain ganglia, the same level, it can go. Second option is above or below that level. And the third option then is it bypasses the splanchnic nerve altogether and goes, the chain ganglia, and goes through a splanchnic nerve, which is what we saw in there as well.
So what would the good option be?
So first, synapse. So the third option, bypass the chain ganglia through a splanchnic nerve, where it will then synapse with a collateral ganglia. And again, a collateral ganglia is just one that's further downstream. So those are the ones that were on the figure that you guys talked about, superior mesenteric ganglia, the celiac ganglia. We go through the splanchnic nerve and then to there rather than at the chain ganglia.
Wait, can you move the website?
All right, that's it. So it took me this long to figure it out, but so I think next semester we will work the worksheets in the middle so that everyone does them
I like it.
rather than at the end and everyone leaves and doesn't do them.
It's more fun.
Yeah.
In class.